Just to make a point about them being a serial arsonist, I'm gonna hunt them down. I'm gonna run them over. Not run them over.
So here is my bit about chapter 7, number 9. Okay. So, and actually, I saw somebody's drawing recently of North America. That was pretty darn good. So here is my drawing. This is Florida. Oh my goodness. Okay, and that's the East Coast. There's Canada up there. Kind of breaks in some. So here's California. Here is Mexico. And it goes down like that. Okay, and then we have the equator down here. So I know that's really bad, but just bear with me. Okay, so this is the Atlantic Ocean, and this is the Pacific Ocean. Okay, and we talked about these. That's terrible, isn't it? We talked about these semi-permanent highs. There, I'm good at that, right? Semi-permanent highs that kind of are at the intersection of the Hadley and the Ferrell cell, semi-permanent highs, that descending air. And so these ocean basins have these big high pressures. And what direction in the northern hemisphere does air go around a high? Clockwise, yes. So here we go, clockwise, okay, clockwise. So actually that was, to me, an answer to this question about if, and this works for the southern hemisphere too, if you look at continents like North America on the west coast, what's going to happen is you will always have kind of this coming from the pole down the coast sort of thing. So to me, that's kind of the balance of our world, is to get, basically take warm water up and cold water down. So oceans are great at that. But what I liked, and I think this came from your textbook, some of you guys put upwelling as a phenomenon, because actually this down, going like this, actually encourages the upwelling. That's very important when we talked about the Southern Oscillation, El Nino, La Nina upwelling. So this sort of going down along the coast ultimately kind of creates a cross current that brings up cold water and nutrients. So I would take either one of those, but that's kind of, and it's not a small thing, because actually if you look at your review sheet for Chapter 7, I think it's on your review sheet. So one or the other, you're going to want to be able to answer this question next Friday. This Friday. Does that help? Okay, so I take either one. Okay. So, so this is the game plan. Yeah, today we'll do Chapter 9, but we won't get through the whole thing. We'll finish up Chapter 9 on Wednesday, and there's a good chance we'll have enough time to go ahead and do a decent review session after class this time. We don't always, but. So there'll be, if we don't have time in here on Wednesday to do a review session, who can afford it will go to the Chem Lab, which is 512. But at 9 o'clock, and about the time I do a 9 a.m. Review session and nobody's there, that's my last 9 a.m. review session. So at 9 a.m. in the same place, yeah, we're going to have another review session. And
Which day at 9 o'clock?
Wednesday.
Me and Kay will be there.
No, I've got.
Oh, no.
I only need one, so you're fine. Yeah, so come if you can. I do record them, and then I put them on, I put a link on Twitter, so, along with my review pages, okay?
What
So
are you doing Friday at 9?
Not that.
Dang it.
I avoid review sessions, like, you can do a Friday, but you can't do a Wednesday at 9?
We don't have class in psychology at 9 o'clock for Friday.
Just this Friday, or usually?
Just this Friday.
Okay. I was going to say it was an ongoing thing, but yeah. But I do record them, so you should be fine. Cool. Yeah, push it on Twitter. So then Friday will be your unit exam in here. Okay? Pulling for everybody. What? Okie dokie.
So do we have one more test after that?
Yes.
And they were done?
No. We have 4 unit exams, but there are 5 units of material, if you look in the syllabus. So that 5th unit of material, which is climates and climate change, so it's cool stuff. There's no unit exam, but you're going to have some questions on your comprehensive final over that last 5th unit. So that's kind of how that goes. Okay? All right.
Oh, I had a question.
Yes.
You mentioned you had the dates on the picture. Is it okay if you just, Walgreens has that little date thing in the corner?
She's asking about the photo project, and I want the dates. And if Walgreen already has the date, that would work. That would work. If your picture already has the date in the corner, that's fine. And the date, it doesn't have to be exact either. It can be just even like within a month and a year. That would be great. So,
Okay,
yeah,
that was weird.
yeah.
I know the exact month.
So, okay. All right.
Can I do mine in a PowerPoint?
Yes, you can.
It just needs to be 10.
10 events, 10 weather events.
And if you have more, what is that in time?
Yeah, that would be fine. I've had people do more than 10, and I count them. Usually I'm like, oh, that is so cool. I love photo projects, by the way. I count them as I go, and I'm like, oh, wow, you're definitely over 10. So you can do more than 10.
And when are they?
Is it extra color?
22nd of April.
Gotcha.
No extra credit. It's just a nice, you have lots. Okay, so chapter 8, we talked about air masses, and I'm hoping you remembered all of that, because now we're going to talk about how when air masses meet, we call that a weather front. So this kind of looks pretty darn dramatic to me. It looks like, if those of you who've gone to spotter training, it almost looks like it could be a wall cloud that's a precursor to a tornado. So pretty exciting. So where air masses intersect, okay, a lot of times there is that frontal lifting. A lot of times there is basically where air masses intersect, a lot of times they clash and one of them will go up. Now, remember I said what's more unstable, something that's moist or something that's dry?
Moist.
Something that's moist is more unstable, exactly. So if you have the thing that's being lifted up, moist air, you can have that adiabatic cooling and you can get clouds to form and precipitation. So that's kind of what we have going on with two fronts that are meeting, and one kind of lifts the other one up. So that can be very dramatic. So we have actually, and there's a 5th one coming up there, but there's 4, broadly speaking, types of weather fronts. And we've been talking about them a little bit earlier. So what color is a cold front? It is blue. And what does it have, triangles or semicircles? Triangles, exactly. A warm front is red with semicircles, exactly. Now, it's a straight line. The front is a straight line, but it has the triangles or semicircles actually showing the direction of motion. So in this one right here, this cold front, I can tell that there's cold air here, and it's pushing that way. And it looks bowed backwards to me. But over here with the next door with the warm front, since the semicircles are on this side, actually I can tell that there's warm air over here doing the pushing. Warm air doing the pushing right here. And if you look closely, the stationary front has alternating blue triangles, red semicircles, but they're on the different opposite sides of the line. So with that in mind, we can actually know that we have warm air over here and we have cold air over here. So you can actually kind of tell what that is. Stationary front, the name kind of gives it away. It's stationary. It's not moving. Basically, it's a standoff. No one wants to push. Because whatever's doing the pushing, that's what we call the front by that. An occluded front, I have in my notes to kind of clue you in, but an occluded front actually has 3 air masses. That's how I always remember it. Instead of just a pair clashing, there's actually a 3rd air mass that's kind of in between them.
3 air masses.
What's that? Oh. So these are just kind of random. I killed even more of a tree. But let's go ahead and I looked at the weather map today. One site I haven't gone to much with you guys is Weather Underground, and I like it. I looked at it today. I think I said when we were talking about air masses, it's hard to know kind of where sometimes one air mass ends and the other mass begins. Okay, that's accurate. That's not it. Weather
I
underground.
like these, it shows like the exact what's happening.
Mm-hmm.
Pretty close.
Yeah. It sounds sneaky, weather underground.
By the weather channel.
Okay, so we'll go to current conditions.
That always takes so long.
I got impatient and clicked it again. There it goes. Current conditions. Okay, so what are those white lines? What would you call those?
Isobar.
I would call them isobars, exactly. Now this is a little bit different because it doesn't have the millibar markings. They're just counting on you. Once you see the H, you know that actually you'll be stepping down in barometric pressure along those isobars. So where on here would be the strongest wind?
Probably near that low pressure up there. You see it all.
Mm-hmm. Why?
The isobars are really close to each other.
Yep. I don't know if you guys heard Joshua, that's what I would say too. Strongest wind, tightest pressure gradient. So let's see what we got here. Let's find us. Iowa here. We are here. We don't really have any front going on, do we? To me, when I look at a weather map, sometimes I think, well, what did we have pass by? And to me, does it make sense we're under the influence of a cold air mass? Not only is it cold outside, but you can kind of see that's what last probably passed us. So we have a cold front, warm front, stationary front. I just think this is kind of bizarre, the whole kind of. So what this means is we have, of course, cold air over here and warm air on the bottom side, and they're not budging. It's just kind of there. And I need to talk about that 3 air mass one. Okay, so you see that purple up there? That's the 3 air mass one. That's the occluded front. It's usually purple, and you know it's not a stationary front because the little marks here, this mark and this mark, they're on the same side of the line. It's not a stationary front because they're on the same side of the line. So in case you're colorblind, you know. So before we leave this, I'm going to give this a name. I'm going to call this a mid-latitude cyclone. Sounds scary. And when I say mid-latitude cyclone, I'm talking about that central low pressure up there, a mid-latitude cyclone. It's in your notes. Look at that number. All right. Let's see. I'll go back to my slides, please. Maybe. Okay. So fronts, weather fronts are that line between 2 air masses with different conditions. So a mid-latitude cyclone, we just saw a minute ago in our northeast, that big old L with the tight isobars. And notice we had an occluded front, and from that occluded front, we had swinging down off of that occluded front, we had, bless you, we had on the left, we had a cold front, and on the right, we had a warm front. That's characteristic of a mid-latitude cyclone. So a mid-latitude cyclone it's kind of a busy sort of thing. It's got multiple fronts. We'll be talking more about a mid-latitude cyclone. In case I forget, because I forgot in my night class to mention this, but if you've ever listened to the song, the Edmund Fitzgerald, yeah, so the sinking of the Edmund Fitzgerald, it was a mid-latitude cyclone that basically creamed that ship. Mm-hmm. So the nor'easters, those are mid-latitude cyclones. They go by different names, kind of by where they are. So a little bit more of kind of throughout this chapter 9 about a mid-latitude cyclone, since it's basically got everything. So here's another picture of a mid-latitude cyclone. This looks like more what we saw today. You see the characteristic central low pressure. And then we have the occluded front right next to the low. And then it almost looks like a mustache to me sometimes. Okay, it does. We have the cold front and the warm front. But even there, can you kind of see three sectors of air? Three sectors of air. We have this cold air, we have this warm air, and we have this cool air. And kind of related to chapter 8, that cold air is moist. Oh, sorry, dry. That cold air is dry, continental Pacific. That warm air, look, what is it dry or moist? It is moist. Maritime, very good. And then what about this one over here, this third sector? Moist also. So one of the things about air you knew before this class is that in your house, if you have a 2-story house, it's warmer up there and it's cooler down here. Warm air will tend to rise. Cool air is more dense and it will tend to kind of seep, the gravity will kind of kick in. So keep that in mind. Now what your author's done, I like. Do you guys see this A and this B? And there's a line between A and B. So that actually is right here in his inset. Okay? So basically it says if you go from A to B, you're going to go through all three sectors of air. You're going to start at the continental polar, you're going to go through the maritime tropical, and you're going to go all the way to the maritime polar. And that's kind of what's shown here. But notice that we have a bit of lifting going on. We'll talk about this lifting separately when we talk about cold fronts. The cold front has lifting. And also there's lifting going on at the warm front. Oops, goodness. So I want to we talked about mid-latitude cyclone has all three types of major fronts. Actually, it starts out with a stationary front. So let's look at the fronts individually. So a warm front is characterized by warm air is less dense than cold air. So I kind of think of it as almost like a mosh pit sort of thing, where kind of gently the less dense warm air goes up and over the dense cold air. And we call that overrunning. And so anytime you can get air lifting like that, it's what we talked about earlier. Air that goes up will expand and cool down. So that cooling air can go ahead and condensation can happen. We can have clouds form. So this is where I like to say, if your folks ever told you look at the moon and if you see like a halo around the moon, that could mean that we have precipitation coming. And they're right. That's most likely or possibly caused by this overrunning. So, because if you're here, if you're a little person here, what you're going to first see are those high clouds that are going to cause those optical phenomena we talked about, the halos and the, what's the other one? Coronas. And then you're going to see another flat cloud, but a little bit lower, cirrostratus. And then you're going to see another flat cloud, but a little bit lower, altostratus. And then, of course, nimbostratus is you get your precipitation. So that's all, that overrunning is moving towards you. So when I think of a warm front, this is what I think of. Notice the caption down at the bottom here. This is a warm front, assuming that the lifting is lifting relatively stable air. So if we compare that to this one, this is also a warm front. And actually, there's been some semesters I don't even include this, because this warm front now is actually showing the air that's being lifted, or a situation is what we call conditionally unstable. Like, oh my gosh, not conditionally unstable again.
What does that mean again?
It means that if your environmental lapse rate is between your WAR and your DAR, then it's unconditionally stable. So, but to me, what I think of it is it's almost like, well, it needs moisture, and your environmental lapse rate needs to be a certain place. But notice that, and we talked about clouds, of course cumulonimbus are your storm clouds. So now we do get some storms with this type of warm front. One of the things, and we talked about this before, is we could have temperature inversions. And remember what temperature inversions allow for is that last kind of mixed precipitation. The whole, you can have, basically your snow falls through a place and it melts and then it refreezes again. So you can have your sleet or your freezing rain. So those are relatively gentle slopes, whether it's a cold, it's stable or unstable warm front, warm air being the aggressor. Here's a good summary that your author has of what you would expect, and we have one of these for the cold front too. What do you expect when a warm front, before the warm front, as the front passes, and after the front passes? So I know up here there's been kind of some talk about what direction the wind is. So here in our neck of the woods, or the northern hemisphere, you would expect before it, the wind's going to be kind of east, southeast. Okay, and then afterwards, it's going to be more south, southwest. Another thing, and we'll talk about this when we talk about pressure, barometric pressure. Whether it's a warm front or a cold front, the pressure should be, remember we said if your pressure is falling, then you expect cloudy skies, maybe precipitation. So you would expect the pressure, barometric pressure, to be falling as these approach. Okay? And then it should rise after the front pass. There's like, when we talk about weather forecasting, a lot of times animals can sense pressure. And so they will actually respond to something that we can't really sense. They can sense that, yeah. Okay. So that was the warm front, and now cold front. You guys told me it's a blue line with triangles, cold front. And since cold air is more dense, then I think of this as almost kind of like a steam shovel. Basically, it's hugging the ground, it's ramming into warm air, and so basically that warm air is being shoved up. And if there's moisture in that warm air that's being shoved up, that the cold air is moving into, then it can go ahead and form clouds and precipitation. And that abrupt, we call it the transition zone, okay, is just very kind of straight up and down. Now another thing that's actually significant is cold air moves faster than warm air. Okay. So this cold air moving faster than warm air is going to be important here in a minute with occluded fronts. So a cold front is one source of severe weather, bringing severe weather. So here is what you expect with the cold front coming through, which in the summertime we like the cold fronts. In the wintertime we don't like the cold fronts. Oh, yeah. So, okay. So this was actually something a little bit new for this edition of my notes anyway, for this textbook. This idea of if you're on the East Coast, you can actually, or Northeast, you can actually have kind of a phenomenon coming off of the Atlantic Ocean. Remember that semi-permanent high? I know I butchered the figure, but at the Atlantic we have the high over there. In the Pacific we also have a high. And so that actually can push maritime polar, so it would be moist, cold air on shore. I was looking at this today because I hadn't looked at it really closely. So if this is this is number 1, and of course this one was over here, number 2. So if you're over here minding your own business at like Boston, Boston's in the 70s. Okay, I don't know if this is maybe the next day or something, but now Boston is in the 50s. Oh, drat.
I live here, yes.
It does happen that abruptly. That can't be good. Does it when the temperature changes? Do you get a lot of wind, or you don't? Do you remember?
Yeah.
It seems like it's windy and temperature change. So yeah. Worse than Iowa. So that's called the northeast backdoor cold front. So a stationary front is alternating red, blue, and the semicircles, triangles be on either side of the, I almost said reaction arrow, be on either side of the front line. So you can distinguish it from an occluded front. And they're just sitting there, no one's winning out. So if you watch a stationary front long enough, probably somebody's gonna win. Oops, sorry. So stationary fronts, they can have some sort of precipitation happening, but it will be happening because of the warm air going up and over the cold air. So that's that overrunning. I see you guys moving those big sheets. Oh my goodness. Okay, so an occluded front, I said, was the 3 air mass thingy. So to me, what's important, actually I'm going to show you two different occluded fronts, but I really can't hardly tell the difference between the two. There's a cold type and a warm type. But what they have in common, occluded fronts, is basically you have a cold air mass that is outrunning the warm in front of it, because I said cold air moves faster than warm air. And as it outruns it, it basically catches up with a third sector of air on the other side of the warm air mass, kind of from west, in our case, to east. So in here, and we call it air, the air is occluded, or it creates what we call an occlusion. So right here, to me, this is the air that's being kind of lifted up. This is air that's aloft, because when you look at these fronts, they're actually what's on the ground. So air that's being lifted up. So 3 sectors. So like I said, we have a cold type and a warm type. So hopefully you see the mustache thing, like I call it, okay? Mid-latitude cyclone. You can kind of tell where it's at in its maturity, because notice, does this one have an occluded front yet? No. So that's kind of early on in its maturity. As it matures, it should get an occluded front right here. So again, with the A, B, what your author's done is kind of shown cross-section, kind of right across that mid-latitude cyclone, kind of the 3 different sectors. This cold air is outrunning the warm air in front of it, ultimately going to lift it up here in a minute to make an occluded front. And that cold air is going to catch up with actually the cool air. So these are just kind of continuations on the figures that you saw a minute ago. Again, so here we have segment A, B. So here, now we have the beginning of the occluded front up there, that purple. And notice we have definitely some uplifting, frontal lifting going on there. I've heard the weather associated with an occluded front, I've heard it's most like a cold front. Okay, occluded front and cold front, we definitely have potential for some severe weather. And this one down here, in a minute, I'm going to actually call, this like elongation. It's basically just the elongation of the occluded front. And your textbook would describe, at this point, it's just kind of the occlusion, or the occluded front, is cut off from, now it doesn't look like a now it doesn't look like a mustache, it looks like little feet at the bottom of something tall. Something silly and tall. It does look like an octopus. So, all right. So just today, and I need to, my night students, I've already done this, but in your notes where it says, after the word overruns, it says colder, polar, continental air. You need to draw a line through, beginning with after overruns, colder, polar, continental air. Yeah, it's like draw through. And then replace it with, instead what's happening is the maritime polar is overrunning the warm air in front of it. So down here, what I have purple here, that's what you need to put. That makes more sense, because I was reading, I was like, what? What did I say there? So relatively mild maritime polar air overruns warm air in front of it. And see, to me, this warm type is very similar to the cold type. Just like, I don't know. So again, we have 3 sectors of air when it's fully occluded. 1, 2, 3. What's happening? Well, here where it's purple, where we say it's an occluded front, basically this air mass is lifting up this air mass and meeting up with this air mass. So it's cool. Cool. Okay. So for you storm chasers, in the springtime, we can definitely have this like fifth front. So dry line actually is a type of weather front. A dry line is a weather front. And of course, fronts need to have 2 air masses. And in this case, a dry line, both air masses are warm. So we have 2 tropical air masses. We have a dry, warm air mass, which would be continental tropical. And then we have a moist, warm air mass, maritime tropical. And where they intersect create a dry line. They call it a dry line because they're both warm, but they're just difference in moisture. So here we go. Forget this guy for now. He's not part of the dry line. The dry line is right here. Dry, warm, and moist warm. So the moist warm is coming up from the Gulf, okay, and the continental tropical is coming from there.
It's a pretty high dew point.
Yes, there's definitely some drastic dew points differences. So notice, like, if we take these 2 locations, remember the top number is the actual temperature, and the bottom number is the dew point temperature. So we said that if this is only 6 degrees, probably Fahrenheit, there's only 6 degrees here, that means it's pretty moist. And there's, 30 degrees here. That is a crazy difference between dew point temperatures. So the way this works then is that actually the drier air, which is here on the left, is denser than the moist air is moving into. So if it's denser, then actually that warm moist air is going up. So then what are these, you think?
Tornadoes.
Yep. Those are the tornadoes, yes. So dry lines are where folks can actually try to find some activity. The thunderstorms, not all thunderstorms bring tornadoes. We'll talk about thunderstorms and tornadoes or no tornadoes. But there you go. Okay, so I'm drawing a blank. So there was a sitcom. Have you guys ever seen the one where they're in Norway? Is it with the? It didn't get renewed. No, okay.
What is it?
It's a Norwegian, and he was a drummer in a famous band. We have to ask my husband. Okay. Anyway, so there's 2 ways that we can get these mid-latitude cyclones, and this one actually has to do with. Dun, dun, dun. Okay, so this is the ITCZ. Okay, so what cell is this one? Hadley, yep. And what cell is this one? It is 2 R's, 1 L. And then what cell is this one? Polar. It is the polar, exactly, very good. So we said right here, actually this is a relatively low pressure. The other thing about right here is we have the polar front. So you figure we have warm air clashing with cold air. Oftentimes we can have a stationary front. Ooh, let's go ahead and draw that in. So we have triangle, semicircle, triangle, semicircle, triangle. You guys buy that. That's our stationary front. And in this model of a mid-latitude cyclone, it starts with that right up there. Now there's another model called the conveyor belt model we'll get to actually on Wednesday. How do you get a mid-latitude cyclone? But it starts right there. All right. So mid-latitude cyclones. We need to have our low. Okay, this is a mid-latitude cyclone in full swing right there. But like I said, what that's missing is the occluded front there, at the middle of the two pieces of the mustache. And it's coming. Seems like we already did this one. It's like a repeat figure anyway. Well, we'll kind of finish this thought. Okay, and then this looks familiar too. Kind of talking about the steps of a mid-latitude cyclone. Does this one have an occluded front? Yep, I see the occluded front too. Oh, I know one thing I want to mention is that around a low, what direction does air move around a low?
Counterclockwise.
It does move counterclockwise, exactly. In our hemisphere, yep. It goes counterclockwise in the northern hemisphere. So I think of it's almost like if you have a central low, it's kind of like a big mixer. It just kind of has arms out. It goes mixes. And actually that's kind of what's going on here too. So this was the third figure we saw before. This is the one I put the word elongated on. Okay. Your occluded front becomes longer. Too much flipping. I don't think I like that. Okay. Yep, I wanted to get to this slide today. So, I know I only had like three figures, but actually within those three figures are these. So I told you, according to this model, it starts out as a stationary front between the ferrule and the polar cell. There you go, there's your stationary front. It develops what we call a wave, a gentle wave, kind of a kink. But do you buy this at number 2? Does it still look like a stationary front to you?
Yes.
Ah, me too. It's just got a little wave in it. Okay. What about here? Nope, it's not a stationary front. Here at number 3, it finally we start to kind of see this distinctive, in the northern hemisphere, on the left is going to be our cold front, and on the right is going to be our warm front, kind of breaking up into 3 sectors of air. Okay, let's go on down to here. Notice what's the difference between that number 3 and number 4?
The low is more defined.
The low is more defined. I buy that. And there's an occluded front, both of those. Yep, there's an occluded front, exactly. So notice then, to me, the difference between 4 and 5 is just kind of elongation. Okay, and then what about 6?
Just on the other side of the high pressure.
Yeah, you would say 6, there's really no weather fronts there. It's just kind of, the air has gone about its way, and anyway. So this one, I'll let you fill in these blanks. So you have any blanks here to fill in? No. Okay. But this kind of summarizes the 6 steps you saw before. Okay? All right, and that's a good place to stop. So we'll see you on Wednesday.